Hello guys, welcome back to a brand new video. Today's day 5 already. Uh I want to do something a little different starting this video. Alright. Let me get out this notepad. Alright. I just want to make a little like stat tree of what we're looking like, so far into the daily LeetCode, hacker rank. Today is going to be NeetCode. Our stats into going through these things, right? There's a lot of things I do want to learn throughout this series that we are, hopping on every single day. So yeah, let me just say, for example, what I mean by stats is kind of like in a video game, like you have different like allocated like literally like stats. Like you have strength stat, dexterity. This is not Elden Ring, but you know what I'm saying. My goal is every single day to every single time I solve a problem and I understand it fundamentally, I can add one stat point towards that certain skill, quote unquote. And yeah, so let's just say for example, arrays. There's arrays. I'd say the stat, like my stats for arrays. I'd say algorithms, even though like all of these are technically algorithms. But yeah, I'm still gonna add that, right? I'll probably like clean it up and, you feel me, make it more understandable, make it more realistic. But yeah, we got arrays, we got linked lists. I'm gonna hop on that real soon. I'm not trying to rush into it, but we're gonna hop on that very soon. We got linked lists, we got and when I say linked lists, I mean like anything, like how to reverse a linked lists. I want binary search trees. Don't know what that means yet, but yeah, we hear it all the time. So binary search trees, linked lists. Don't mind Harissa. You feel me? So I'll say arrays, algorithms, linked lists, binary search trees. What are they other different? Just gotta go through. You saw that not so long ago. Let's see. So there's data structures and algorithms. I say arrays is part of data structures. Linked lists is binary search trees. Algorithms is also what I was talking about, like the logical portion. I don't know, like I'm not favorite. I pretty bad basic algorithms. But let's use the most advanced things. I'm gonna improve slowly. So it's okay. So we got these. It's dynamic programming. Get the big leagues. Okay. Here. Yeah. I think I don't know what's clicking, but I questions. Okay. You see. It's integrams. Okay. Yeah, let's hash tables too. What's these hash tables? Don't know what it means yet. I'll look for suffering. On my Friday, know. That first research, I realized I don't know much. Databases, I could. Matrices and priority queues also seem to be just like that. Double linked list, back to that enumeration. Oh, bad math as well. Let's get our math stats. I think that's enough stat tables. I'm probably gonna delete like a good portion of these and add some more, clear it up before the next I was just gonna say episode, but we could just say it's a series, so it's the next episode and things of that nature. All right, man. I think that's gonna be the stats for our Jinachon. So I'm just gonna make a little more fancier. Alright, I'll probably skip this portion. Alright. Alright, I like this, I like this, I like this. So, for arrays, I'd say we've done a fair amount, of array problems the past couple of days. I'd say like we're gonna give ourselves a humble 3. Algorithms. I'm not too sure if we've done that many algorithms problems, but I knowing myself, I'm also gonna like neglect myself too, like I always do. I'll just say 2. Linked list is 0. That's a lie. Probably like 0.5. Did some studying off camera or off recording. BS zeros. Just a bunch of zeros, let's be real. I don't even know what half of these means. Databases, we're just gonna say 0. Math, 1. Alright. These are our stats for for day 5 into the series, I think we're gonna start tapping into. Today we're gonna be specifically tapping into I'm assuming lists, yeah, arrays, and a little bit of math. I didn't really read the problem too much. Let's actually just jump straight into it. So we got an integer array. So we have an integer array of numbers, and we have to return true if any value appears more than once in the array. So we're just trying to detect as a duplicate. Otherwise, return false. Okay. So yeah, 133, 1, 2, 3, 4, everything's okay. This seems pretty simple. Believe it or not, I've never done a problem like this, so I might have to hit up Visual Studio Code just to like debug a bit. But yeah, let me save this real quick. See that? Okay. So okay. So we have a list of numbers which we could probably loop through. No, I don't want to make it like, you know what I'm saying? I don't want to make it too inefficient. My first thought was a for loop, which probably is the right tool to use to solve this problem. Probably check the first value, loop through the rest of the values, see if they're equal. But that's so inefficient. I feel that's just way too inefficient. I feel that's my last result to solve. I don't really I understand what like log n or log, you know what I'm saying, or like what's it called, these terms that they use, like these software engineers, bloody software engineers, they use this like the amount of operations, so it could be n squared. It's like a zero symbol. Let's see what it say. Log n time complexity. Yeah, O log n. So whatever. Pretty sure that's like the most optimal one. The one I was about to say, the for loop, where I literally check the first value in the index compared to the rest, that has to be like n to the power of 80 something shit. Like, I don't know. Oopsies, I didn't need to say that word. Okay. I think we should 100% have a ooh. So we got list of integers and returnable. So for I nums. So checking through each number. Ooh. So if we do 4 I numbers and oof. Are they ordered? If they're ordered, I can make a pretty simple solution. If they're ordered, I could probably force it to be ordered and then do this little sneaky move I'm thinking of. Okay. So let's try ordering it. We're gonna use a little cheat. I don't even think this is legal. And then I'm gonna check the solutions and see what was the most optimal method and try to understand it. We're gonna hit the MS Paint strat. We're gonna try to visualize our understanding. Make sure it's clear in my head, clear in your head. Yeah. Let's just get into it. So I'm thinking of hitting up nums.sorted. We're gonna say like nums is equal to nums.sorted. So we'll sort the numbers. I could just Google that just to make sure it's an actual sort number arrays Python function. So I cooked. All right. So now we have the numbers now. The list of numbers is sorted. If it wasn't already sorted. Now we're gonna do one for loop. For I in range 0 to length of the numbers. So we're going to be looping through 0 to the last index in this list, and we're basically going to say if num I, the current number we're at, right, is plus e. Okay, so if num I, the number we're at, is equal to num I plus plus, which I'm pretty sure is just I plus 1. I'm just going to do this in case. Or num I. So if either one is true, num minus 1, then we're going to return true. Else, no. We're just going to keep going if it's the case. If we go through the entire loop and all seems good, we're just going to return false. This is probably the only solution I could think of right now. We're going to run it. Please, dear God. Oh, I didn't even have a login to begin with. Okay. Let me just copy this to this. It's bugging a little bit. I think my logic is quite sound though. Nums equals nums assorted. Oh, I see. It's just weird. We don't care. We don't care. Sign in. I'm gonna have to cut this out probably. Alright, we're back. Gonna paste that in. Alright. So they are sorted. I mean, I'm assuming we're gonna run this. Out of bounds, I'm assuming. Oh. Oopsies. Silly me. I minus 1. Did I do something again? Yeah, I did. Bunch of errors. Test case 1. Test case 2. Index out of range. I see. So it can't check all the way through. Let's do length minus 1. And my thought process is, since this will loop to the last one or before last, it's gonna check the next one. If you get my drift. And it works. Wrong answer. Alright. Yeah, so it can be random. That's what I don't like. I want to sort it. I could actually check around. Alright. That's the solution. Alright. So I said it's false. I guess I didn't sort it. Let me see. Nums is going to be nums sorted. doesn't exist. Oh my god, that might be just my question all decision. I'm not too sorting things. Ooh, that's the name of it. Okay, so I might have cooked. Chat, I did not cook. Oh, I did cook. It was just my past problem. Okay, bet. One simple Google search. I learned sort and sorted around brackets is completely different. Let's see a solution that's the most optimal, because I feel like that was not the best. Let's watch this, guys.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve contains duplicate. This is another problem from the blind 75.
I love NeetCode, bro, but I'm not trying to watch this yet. Drawing explanation. Oh, bet. Oh, he's explaining the law, the nah, whatever.
Then we have to check, is the second number a duplicate? How do we know? We have to compare it to every other number. We do the same thing with the third one.
That's what I thought so too. That's n squared, yeah. I feel like a South Ranger sometimes. Oh, yeah. That's also not worth it.
Used by the sorting algorithm. So in this case, we hash set gonna do for us? It's gonna allow us
what the hell is a hash set?
Input, but we use extra memory. We use a hash set. But what exactly is a hash set gonna do for us? It's gonna allow us to insert elements into the hash set in big O of one time, but it's also gonna allow us to check. We can ask our hash map, does a certain value exist? We want to know, does this 1 exist in the hash map? Well, if we start at the beginning of the array, so far nothing is in our hash map, so a 1 does not exist in our hash map. That means this 1 is not a duplicate. You can see that this is an improvement over the brute force. Previously, to determine if this was a duplicate, we had to check every other value in the array. This time we don't. But after we have checked if this is a duplicate, we do have to add it to our hash set, because later on, if we encounter a 1, like over here, then we determine that this is a duplicate because we know that there's already a 1 in our hash set. So next we're gonna check 2. 2 is not a duplicate, add it here.
I get it. But how, what's the code? Let's see this.
Code now. Okay, so now let's get into the code. So the first thing I'm going to do is create that hash set. In Python, you can do that just like this. It's just called a set. And then the simple thing is just going through every value in the input array nums. And before we end up adding it to our hash set, because remember, we want to add every one of these values to our hash set just like this. But before we even do that, we want to know, is n a duplicate? Does this value already exist in our hash set? And if it does, we know that our array contains duplicates. So we don't even have to continue through the rest of the array. We can immediately return true because we found a duplicate. But if it doesn't contain a duplicate, we're going to add that value, then iterate through the rest of the array of nums, and then the loop will exit, and then we can return false to indicate that we did not find any duplicates in the array. Now let's run the code to make sure.
Very simple. Okay. So you're just like, I said I was gonna do it. Let me do it anyways. All right. Drag this to my monitor. So he's an actual. Oopsies. All right, I did a little oopsies there. So he's an actual wizard, actually. So he sets it to a hash set. I know what set is. I'm assuming hash set. The 8 it's just something like hash label, but later. And it's a set is gonna be a. Could you do something? Just check. It's true. I think you could. I'm gonna go by this anyways. So he's gonna set data type, which I forgot the properties. I looked this long ago, but I'm pretty sure it's mutable. It's mutable. It's also, I'm pretty sure you can find the location. I'm not actually I'm studying really sets, but it's kind of an array. He appends a value to sets to this h sets variable, and then he appends only at end. So he has a for loop for yap. He first checks if the nums value, so let's say nums I, these numbers, exists. He checks if it exists. Okay, so in h set. If it does, return true. That is good enough, so you just appends it. So you appends that value to h set. Pick fully loop without it technically exists, which is false. Yep. Thank you guys for watching my TED Talk. Damn, this is hideous. I'll see you guys in day 6 tomorrow.